Singh. I am working with microservice team under platform of Squad. Today I am here to talk about distributed mapping, which is a new feature in AWS services, particularly in step functions. Before we move forward, let us see our problem statement. So we know that as humans we tend to reduce our tasks completion time. So for that, what we have to do? We have to follow one or another ways to reduce that time. One way is that make many people do one single task. But if what if the resource that we have is limited? What if that men that we're talking about are limited? Then we have to follow another way to complete our tasks. That is, one resource has to do multiple tasks. And this particular way or concept is known as parallelism. When a resource is doing one task at a time, that means that's serial processing. But when a resource is doing multiple tasks at a time, or a process is doing multiple tasks at a time, that's called parallel processing. So today we will be seeing how parallel processing is done by using AWS, and in particularly how we are doing this using distributed mapping function. So now we know that our problem is that we have to do multiple tasks in limited time. So let's see how we are facing the same problem in AWS in cloud. When we want to do some particular tasks, we use Lambda. Lambda, which is a serverless function. This serverless function is used to perform or manipulate various AWS services such as EC2, time series, and S3 bucket, and many more. But this Lambda has a time limit. That time limit is of 15 minutes. So whenever I am using this Lambda to perform any particular task, that task will only be executed for 15 consecutive minutes, and after that it will show time error. So if I have to perform any process that is taking too long, more than 15 minutes or 1 hour, then I want to do or perform that particular task in a single Lambda. So here what can I do? Now I have to use multiple Lambdas to perform this thing, and I have to connect those Lambdas as well. So, in order to do so, I have to use another service of AWS, and that service is step functions. So, what is a step function? A step function is an orchestration of lambdas. So, basically, it's an orchestration of serverless services. In step function, we can connect various lambdas, and by connecting those lambdas, we will be able to perform multiple processes. But over here also, we are facing various problems. So, let's see this solution first. In this solution, if we connect various lambdas together in a serial way, so now we have discussed about the problem. So let's move towards the solution, the possible solutions that we have. So the solution that we came up with for the time of error in lambda function was using consecutive lambdas in step function. As clearly seen in the screen that we are using consecutive lambdas one after another, and this is a serial process. As we have discussed earlier, what is serial processing and what is parallel processing. So the serial processing is when we are doing one task at a time, and parallel processing is when we are doing multiple tasks at a time. So right now we are performing serial processing using lambda functions. So if you are using serial processing in the step function, then we have to use lots of lambdas, because if you have to perform a process which takes 1 hour, then we have to use how many lambdas? 1 hour divided by 15 minutes. So this will be a lot. So if you have to perform a process which takes 4 hours, then we have to use more lambdas. So it will increase the length of the workflow. And also we have to use each and every lambda. So if the process takes 1 hour, it will take 1 hour. We are not optimizing the time. So right now we are having two flaws here. One flaw is that the workflow is quite huge, and second is it's consuming too much time. And thirdly, when we use step functions, the event history has a default limit, which is 25,000. So if the lambdas are increased, we won't be able to access the event history, execution event history. So for that also we have to find some new solutions. So let's see those solutions. So the another solution that we have found was using lambdas recursively. So how can we do that? We have to use another feature of step function, which is choice. What does this choice do? It controls the flow of the step functions. So how does this do that? It does that by using some conditions. Those conditions could be used to control that flow, and by using those conditions we can also call the previous lambda recursively. So what does this thing do? Now we don't have to use multiple lambdas to perform those tasks. Now we can use single lambda that will be called as many times as long as the process has not been finished. So our first problem, that our workflow is quite huge, has been solved. But still we can see that this lambda will be called multiple times. So if we have to process a task which will take 1 hour, still it is taking 1 hour. So we have to solve that problem as well. And the another problem was, this execution history will be only limited to 25,000. So we won't be able to access the other execution history if our lambda has been called multiple times. So let's see the other solutions for this problem. So now, in order to reduce our time, we have found another solution, which was to use inline mode. Now inline mode comes in the state name map. In this, we can do 40 parallel processes, and it also reads the data from JSON array and then parallelly processes this data. Now our first problem was solved initially by using recursive choice, and now the second problem has been solved using inline mode. Now still this inline mode is not that much useful, because if you want to process some processes which require machine learning, or we have to do some real-time streaming, still it won't be that much efficient, but it is better than the previous choices. And also still the third flaw that we had was, we are unable to store event history when it is more than 25,000. So in order to reduce our time, we have found another solution, which is to use inline mode. Now this inline mode comes under state name. So in this inline mode, we can use 40 parallel processes. So now our second problem has been solved to process multiple tasks at the same time. But still 40 is not enough, because if you want to process some machine learning, or we want to use some services like Kinesis or EMR, we still need some high level multiprocessing. But still it is better than the previous choices. And the third problem is still having some flaws. The third problem was, the execution event history has a hard-coded entries that has a limit of 25,000. So still, if we are using inline mapping and our function is having more lambda function in them, running in them, then we won't be able to store execution event history. So to solve this problem, we have to use another solution, which is distributed mapping. Now in this distributed mapping, we can run 10,000 concurrent processes. Even though our lambda by default has 1,000, which can be increased, but still we can run 10,000 concurrent processes. And that's better than the inline mode, but it also helps us to store the entries of execution event history. And how does this? It does that. Basically, whenever we use distributed mapping, it has child executions, and those child executions have its own execution event history. So every child will have a limit of 25,000 execution history. So the third problem has also been solved. So what are the other benefits that we can avail by using distributed mapping? The inline mode only is accessing JSON array. But as you can see here, that distributed mode is using S3 object and CSV file as well. So this is far better than the inline mode, even though it depends on the use case. But still, as our objective was to increase the parallel processing which is being implemented by using distributed mode. So this was our solution on this problem. So now let's move to the implementation. So we can see that, are we really able to call concurrent lambdas? So here you can see that we are using S3. Now S3 is also Amazon service which helps us to store things as objects. So here we can store images, videos, even CSV files, but as objects. So here we are reading data from CSV file, and then we are using distributed map through which our S3 files, that are objects in our S3 files, will be accessed by lambda and then processed. And it doesn't matter that how much concurrency that we have given. If the objects in our CSV file are 90, 100 or 200, we will use that much concurrency. But we can adjust that as well. So now here we can see after executing our step function, how it will look like. It will show a green color if it has been successfully executed. It will show red if it is terminated or there is error. It will show yellow while processing. So here comes green because our execution was completed successfully. But what kind of output you want, whatever kind of output you want, you will be executing that lambda multiple times and parallelly. And you can easily see that here. In CloudWatch logs, you can easily monitor and you can see that how many lambdas are invoked at what time. So here we can see that in our S3 bucket, we are having 90 images in this implementation. So when we use distribution mapping, even though our concurrency limit was 1000, still our lambdas were invoked, 90 lambdas were invoked together, and through which we can easily conclude that distribution mapping could be used to perform these lambdas parallelly. Let's talk about the use cases. So there are various services in Amazon which can use distributed mapping mode. But today we will be talking about these 5 services. So one of the services is EMR. This is a fully managed service which uses Apache Spark and Hadoop in order to process large datasets. So if we use distributed mapping mode, we can split those large datasets into small parts and then we can process them parallelly. And through this, we can complete our task as quickly as possible and it will increase our efficiency. Same goes with Amazon SQS and Amazon Kinesis. In both these cases, we do real-time streaming. And if we use distributed mapping mode in these cases also, we can improve the efficiency. And when we see Amazon SageMaker and Amazon Recognition, in both these things, we process video and images. And when we recall that distributed mapping mode can access S3 bucket, which stores object, so it can store images and videos as well. So we can use that S3 bucket and we can implement it with distributed mapping mode, and we can then easily split those videos and images to make GIFs and do various other processes, and it will increase our efficiency as well. So we can see that this distribution mapping mode can be implemented on different AWS services, and by doing so we can increase the efficiency and we can reduce the time that it will take to process all these things. So now we can conclude that distribution mapping is a critical technique which could make our tasks easier by helping us in running parallel processing, by distributing the tasks. And we have various AWS resources which could easily use this kind of technology in order to make their processes fast and increase that efficiency. So this technology could be used in various places to help us in various ways. This topic, distribution mapping, was a part of my Saturday experiments. Through these Saturday experiments, I get the opportunity to learn new technologies which I could easily implement on my ongoing projects. And in this particular technology, distribution mapping, I learned how I can use this to process parallelly and increase the efficiency of the services in AWS easily. Thanks for watching this video, and I hope that you have learned something new through this video. Thank you.